This video, we'll call this video 7B. This is the third way of doing a limiting reactant stoichiometry problem, and it's using a BCA chart. This is a really good method when the question also asks what mass of excess reactant is left over, because then basically all you're going to do is you're going to fill out this BCA chart completely and you're going to answer both questions. The tricky part of this is figuring out which reactant is the limiting reactant. And how you do that is you look at the change row. You assume the first reactant is the limiting reactant. Then you're going to do a mole over mole stoichiometry problem. Figure out how much of the other reactant you will use. Sometimes you will then wind up with that you would, after the BCA, the after part, you would have a negative number. Well, you can't have negative number of grams. That's matter is never created nor destroyed. So that can't happen. So that means that the first reactant wasn't the limiting reactant. I think you'll see that when we actually go ahead and do this problem. So the question asks, what mass of aluminum oxide is formed from, this looks weird. Aluminum oxide is formed, right, that's the product, from 100.0 grams of aluminum and 150.0 grams of oxygen. And then there's the second part to this question. What mass of excess reactant is left over? And when a question asks for both of these, that's when I like to use a BCA chart. So the first thing we need to do is we need to fill in all the rows. So how much aluminum am I starting with? 100 and then a decimal point grams, right? We know that decimal point, it looks kind of weird there. We wouldn't normally do that in math class, but in chemistry class, we need to do that because we need to show that that number has 3 significant figures. Also, my mass of oxygen has 3 significant figures. And how much product do I start with? None. So now we know that these chemicals are going to react in terms of moles. So I need to convert both of these to moles. So this is, 100 grams of aluminum. I know that 1 mole of aluminum has a mass of 26.98 grams. And so how many moles is that? 3.706 moles of aluminum, right? I'm always going to, or I'm going to try at least, to write in the units and the chemical just because it's real easy to get them confused. 150 grams of oxygen. 1 mole of oxygen has a mass of 32.00 grams of oxygen, and that equals 4.687 moles of oxygen. So write that in here, 4.687 moles of oxygen. And I don't need to do this conversion out. If I have 0 grams of aluminum oxide, I have 0 moles of aluminum oxide. So now I go to the change, row and go to figure that guy out. Sometimes I like to put like a dashed line in here because I don't know which reactant is going to be the limiting reactant. So I may need to do this twice. The first thing that I do, right? So the first thing, convert both reactants to moles. The second thing to do is, is reactant 1 the limiting reactant? If reactant 1 was the limiting reactant, this guy would be minus, I would use it all up, minus 3.706. And that I'd wind up with 0. Can I do that? Well, if I use up 3.706, I'm going to write this up here, 3.706 moles of aluminum, how many moles of oxygen will I also use? This is the coefficients from the balanced chemical equation. 3 moles of oxygen will be used with 4 moles of aluminum. When I do that calculation out, I get 2.7795 moles of oxygen. That would be this guy, minus 2.7795. Now I look, does that work? Can I do 4.687 minus 2.995? Without even doing out the calculation in my head, I go, yeah, I can do that. It's not going to be a negative number. If that was a negative number, that's what it's going to be in the next example, then I would know reactant 1 wasn't my limiting reactant. So this was my limiting reactant because I didn't get any negative numbers that way. Now I need to actually do this out. If I start with 4.687 moles of oxygen, I subtract 2.7795 moles of oxygen, that's going to get used. What am I going to have after, which was going to be left over? 1.9075. That's how many moles of oxygen I'm going to have left over. What about aluminum oxide? That's what the question is actually asking me. Well, now that I know what the change is, I can figure out this by, again, using the coefficients from the balanced chemical equation. And I always start with the limiting reactant. If I use 3.706 moles of aluminum, according to the coefficients from the balanced chemical equation, 2 moles of aluminum oxide will react with 4 moles of aluminum, and that will give me the 1.853. Moles of Al2O3. So that will be plus, right? If the change is negative on one side of the arrow, it's going to be positive on the other side of the arrow. So this is plus 1.853 moles. And then 0 plus 1.853 is 1.853 moles of Al2O3. Now all I need to do is convert those moles, back to their masses. So let me get a green for this, right? If I take 1.9075 moles of O2 and convert it back, 1 mole of O2, 32.00 grams, that equals something. What does that equal? That equals 61.0. grams of oxygen. Now, what is that? That's the oxygen that's left over, right? That's the excess reactant. And then I can take my 1.853 moles of Al2O3. I'm running out of room here. Convert that back to grams. The molar mass for that is 101.96. And that comes out to be 189 grams of Al2O3. So I've actually answered, even though it seems like an awful lot of work, I've answered both questions, right? The first question that I circled, when it said circle to do, what mass of aluminum oxide is formed? That's this. The second question said, what mass of excess reactant is left over? And that's that answer right there. So I can answer both questions at the same time. Another interesting thing that happens when we do a question like this is that I can check my work rather easily. Remember the law of conservation of matter. It says matter is never created nor destroyed. So look at the start of this reaction. The start of this reaction, I have 250 grams of matter. I have 250 grams of stuff, aluminum atoms and oxygen molecules to begin with. A reaction happens. Guys change partners. I have new products that are created, but look at what's 61 plus 189? 250 grams. So I started with 250 grams and I ended with 250 grams, of course, because those guys are still 0. So I like this method because even though it's sort of a lot to keep track of, you answer both questions at the same time, and you can check your work easily by looking at how many grams of each how many grams of matter do I start with and how many grams of matter do I end with. Okay, we're going to do one more of these for practice, and then you guys can start your homework on this. So what mass of Al2O3 is formed from 35 grams of aluminum and 25 grams of oxygen? And then again, another question, what mass of excess reactant is left over? Right, so start from the beginning. I'm going to start with 35.0 grams of aluminum, and I'm going to start with 25.0 grams of oxygen. And of course, I start with no product. I need to convert both of those to moles. 35.0 grams of aluminum 1 mole of aluminum, 26.98 grams. That equals 1.297 moles of aluminum. And then if I start with 25.0 grams of oxygen, convert that to moles. Molar mass is 32.00 grams. What does that come out to be? 0.78125. And this guy is, of course, 0. So now this is the tricky part, I think. Which reactant is the limiting reactant? And so remember, I put little dots in the middle here because I don't know which one is the limiting reactant yet. And the first thing that I said was assume reactant 1 was the limiting reactant and see how that works. So if this guy goes down by 1.297, how much will the oxygen go down by? And in order to do that, I need to do a little stoichiometry. That if I have 1.297 moles of aluminum reacting, how many moles of oxygen will also react? I look at the coefficients from the balanced chemical equation. 3 moles of, looking at the coefficients here, 3 moles of oxygen reacts with 4 moles of aluminum. So I do that, multiply by 3, divide by 4. The number that I get is 0.9735 moles of oxygen. That would be the number of moles of oxygen used. Look what would happen if I tried to use 0.9735 moles of oxygen. Can I take 0.78 moles and use 0.97 moles? No, that would come out to be some sort of negative answer here in the after. So what that means is that can't work. That is not right. So this is not right. It must be the other way around. What must actually happen is that reactant 2 must be my limiting reactant. This guy must go down by 0.78125, and then wind up with 0, because that was wrong. And this guy must go down by some number. I don't know that number yet, but it's going to be 0.78125. Use your units here. Moles of oxygen. I want to find how many moles of aluminum I'm also going to use. 4 moles of aluminum, 3 moles of oxygen. What does that equal? It just equals 1.0416. So this guy is going to go down by 1.0416. Now, can I do that? Can I take 1.297 and subtract 1.04? Yeah, that does not come out to be a negative number. That comes out to be 0.2554. This is how many moles of aluminum would be left over or in excess, because now the oxygen is my limiting reactant. How much aluminum oxide am I going to make? Well, I'm going to need to do another stoichiometry problem here. Remember, now that the oxygen is our limiting reactant, this number of moles of oxygen is how much is going to be used. So 0.78125 moles of oxygen. And again, according to the coefficients from the balanced chemical equation, 2 moles of Al2O3 will be used for every 3 moles of O2. What does that number come out to be? 0.5208. So this guy is going to go, again, plus, because it's the other side of the arrow. The other side, it's a product. So 0.5218 moles of Al2O3. And if I take 0 plus 0.5218, I'm going to wind up with 0.5218 moles of Al2O3. Now convert those back to grams by using their molar masses, So let me get a different color here, Convert this guy back to grams. So 0.2554, that's moles of aluminum, 1 mole of aluminum is 26.98 grams. And what does that equal? 6.89. So this is 6.89 grams of aluminum left over. I'm going to have no oxygen at the end or after because that was my limiting reactant. And then this guy down here, 0.5218 moles of Al2O3, convert that to grams. 1 mole is equal to 101.96 grams of Al2O3. And what does that equal? 53.104. So, I should, significant figures here, I just got 3. Let me erase that. It's going to be 53.1 grams of Al2O3. So I've answered both questions. The first question says, what mass of aluminum oxide will be produced? That's 53.1 grams. How much of the excess reactant will be left over? That's 6.89 grams. And check your work. How many grams did I start with? Right? So total, I started with 60 grams of matter in the form of aluminum atoms and oxygen molecules. At the end, I ended with 60 grams of matter. Atoms have rearranged, but I didn't lose any atoms of aluminum or oxygen. There's still the same number of atoms. They're just arranged in different ways. But 6.89 plus 53.1 equals 60. So there's 3 different methods for doing these problems. And hopefully one of them made more sense to you than the others. Or there's one that you go, yeah, I really get that. That makes a lot of sense. Then that's the one that you use. You don't need to, how you're going to be assessed on this is those show what you know videos. Pick any method. Either the comparing the have and used, doing the stoichiometry problem twice, or doing a BCA chart. Any one of those will work, okay? I do want you to do a limiting reactant stoichiometry problem. So, use one of those 2 balanced chemical equations, or use one of those 5 balanced chemical equations and do a limiting reactant stoichiometry problem. I would like you to do one that has the question, not just how much product can you make, but which one of the excess reactants is left over, right? So you can either do that using a BCA chart or using the SU, using start minus used equals excess. Okay, ask any questions. And now, after watching videos 7A and 7B, you should be able to do the homework. The homework is going to be the rest of these problems, so 26 through 28. Okay, use any of the 3 methods. I don't care which method you use. Check your work. No matter what method you use, the work may be different, but the answer should be the same. So when you check your answers, you should get the same answers, even if I used a BCA chart and you used need versus have. That shouldn't matter. And start working on your show what you know problem and ask questions on our Q&As. Okay? Any questions, Q&A, or email me.